In today's video, we are going to go through indefinite integration. Indefinite integration is simply the integration that has no upper and lower limits. It can be represented by this symbol. And then we have this symbol which belongs to definite integration. A here represents the upper limits and B here represents the lower limits. So in today's video, we are going to go through only indefinite integration. Now before we go into indefinite integration, let's go through the basics of integration. Now first of all, we have seen in differentiation that dy dx equals nx raised to the power of n minus 1. Now in terms of integration, the n minus 1 is replaced with n plus 1. And then instead of multiplying n by x, we divide by n plus 1. And then finally, we add c, which is the constant of the integration. Now this c must be added to all indefinite integration because we are not sure of its value. So with this, we can say the formula for solving integration is simply if you have the integral of x raised to the power of n dx, it is equals to x raised to the power of n plus 1 divided by n plus 1 then plus c, which is the constant. Now this formula applies for all functions except solving for the integral of 1 over x dx. Now there are some things we have to note. For a function to be integrated, the integral sign and the x must be written. Now let's take our first example. It says if the derived new function is 3x squared, that we should find the original function. Now there is something you have to know about integration. It's simply the reverse of differentiation. So this question said if we have the new function as 3x squared, we should find the original function. So it's simply saying we should integrate 3x squared. So using the formula, when you integrate 3x squared, we have 3x raised to the power of 2 plus 1 over 2 plus 1. And this is going to give us 3x cubed over 3. And then 3 cancels 3 and we are left with s cubed plus c, which is our constant. So as you can see, we have gotten the original function, which is x cubed. So with this, we can simply say integration is the reverse of the process of differentiation. Or we can also say it is the process of finding the original function when the derived function is given. Now let's solve some examples on indefinite integration. So the first example we have is the integral of 4 dx. Now this is going to give us just 4x plus c. Now let's solve another example. We have the integral of 7x dx. We have 7x raised to the power of n plus 1 over n plus 1. And here, as you can see, n equals 1. So we have 7x raised to the power of 1 plus 1 divided by 1 plus 1. And we have 7x squared over 2. So our answer here is simply 7x squared over 2 plus c, which is the constant. Now let's solve another example. We have the integral of 5x then multiplied by the square root of x. Now the square root of x can be simply rewritten as x raised to the power of 1 over 2. So we have the integral of 5x multiplied by x raised to the power of 1 over 2 dx. Again, using the laws of indices, we can add the powers, we can add the exponents of both x in our expression. So we have the integral of 5x raised to the power of 1 plus 1 over 2 dx. And 1 plus 1 over 2 gives us 3 over 2. So finally we have our integral of 5x raised to the power of 3 over 2 dx. Now when we finally integrate, we have 5x raised to the power of 3 over 2 plus 1 over 3 over 2 plus 1. Now 3 over 2 plus 1 gives us 5 over 2. So we have 5x raised to the power of 3 over 2 divided by 5 over 2. Now this simply gives us 5x raised to the power of 5 over 2 multiplied by 2 over 5. And 5 here cancels 5 here, and 2 multiplies x raised to the power of 5 over 2. And our answer here is 2x raised to the power of 5 over 2 plus c, which is our constant. Now let's go on to solve other examples. So we have this example, the integral of 6x plus 12 dx. Now to solve this, we are going to integrate separately. So you can write it as the integral of 6x dx plus the integral of 12 dx. So when we integrate 12 dx, just as we said before, it is going to give us 12x. And then using our formula for 6x, we have 6x raised to the power of 1 plus 1 over 1 plus 1. So this gives us 6x raised to the power of 2 over 2 plus 12x. 2 here goes into 6 and gives us 3. So we have 3x squared plus 12x, then adding our constant plus c. Now let's solve examples with fractions. So we have this example, the integral of 2 over x squared dx. Now the equation can be written as the integral of 2x raised to the power of minus 2 dx. So solving with the formula, we have 2x raised to the power of negative 2 plus 1 divided by minus 2 plus 1. And this gives us 2x raised to the power of negative 1 divided by negative 1. And when we divide by negative 1, we have negative 2x raised to the power of negative 1. And then it can also be written as minus 2 over x, then adding our constant plus c. Another example, we have the integral of 5 over the square root of x dx. Now just as we did before, the square root of x can be written as x raised to the power of 1 over 2. So we have the integral of 5 over x raised to the power 1 over 2. Now we can also write this as the integral of 5x raised to the power of minus 1. So finally, when we integrate, we have 5x raised to the power of minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1. Now minus 1 over 2 plus 1 leaves us with 1 over 2. So we have 5x raised to the power of 1 over 2 divided by 1 over 2. Simplifying this, we have 5x raised to the power of 1 over 2 multiplied by 2 over 1. So this leaves us with 10x raised to the power of 1 over 2 plus c, which is our constant. Now I'm going to give you 2 examples to solve by yourselves. So we have the first one, which is the integral of 3 over x squared plus 5 dx. And then the second one, which is the integral of 1 over x cubed minus 1 over x squared dx. Now, if you have been listening, then you'll be able to solve these 2 examples. I would like to see your answers in the comment section. Now let's move over to the next part of this lesson, which is integration of polynomials. That is integration of polynomial expressions. So we have this expression, the integral of 4x cubed plus 5x squared minus 2x plus 7 dx. Now, one thing you have to know about integration of polynomial expression is that when integrating polynomial expression, you integrate them term by term. So this example we are going to differentiate them into different terms. So we have the integral of 4x cubed dx plus the integral of 5x squared dx minus the integral of 2x dx, then plus the integral of 7 dx. So when we integrate, we have 4x raised to the power of 3 plus 1 divided by 3 plus 1. Then when we integrate 5x squared, we have 5x raised to the power of 2 plus 1 divided by 2 plus 1. Then minus, we have 2x raised to the power 1 plus 1 divided by 1 plus 1. And then we have 7x, which is the integral of 7 dx, then plus c, which is our constant. Now when we integrate this, we have 4x raised to the power of 4 divided by 4 plus 5x raised to the power of 3 divided by 3 minus 2x squared divided by 2, then plus 7x, then plus c, which is the constant. So 4 here is going to cancel 4 here, and 2 here is going to cancel 2 here. So we have x raised to the power of 4 plus 5x cubed divided by 3, then minus x squared plus 7x plus c. So basically, when integrating polynomial expressions, you just divide them into different terms, then differentiate them individually, then finally you add your c, which is the constant. Okay, this is going to be the end of this video. Now, for further understanding of integration, you can find other examples and practice. Now you can go to your textbook or go online, search for other questions on indefinite integration. Good luck. See you in my next video. Bye.